This is another one important topic though. Scheduling, remember, scheduling is one important topic and it's very vast. 4-5 processes are there. Hardware software partitioning is another one important topic. Okay, hardware software co-design, partitioning, many terms are there. We'll see. Okay, and without this, no embedded system will work. No embedded system will work. Anything till here, till just understand that everything which we do, okay, in embedded system have these two things, hardware and software. Okay, and it is very important that who takes over more control, hardware or software. Are you getting or not? This is very important. So that's why there will be sometimes a little portion of hardware, there will be some little portion of software, but there is also, some sacrifices to be made between them, hardware and software. Some sacrifice we need to make. Okay, so that's why there is always a thing called trade-off. Whenever you need performance, there need be something like you need to sacrifice with quality. If you need quality, you might have to sacrifice performance regarding different designing of your hardware and software. This is called as hardware software co-design. Okay, and there are many algorithms. Again, we'll not go very detailedly in each of the algorithm, but we'll see 1, 2, 3, 4, around four or five. Okay, algorithms. Just give me some minute. They may this. Anale, okay. I think I'll give this as your self study. They may. Can you see this? See this, Anna? This part. If you go in VLE lesson 1, I think that is also not uploaded. Analu, in this, I'll upload this file as architecture of embedded system. Okay. You make a note from here, Anale. Okay. From this point till here, till here, till here. Page number page number 8, 9, 10, 11. Page number 11 and 12. Page number 8, 9, 10, 11, 12. This is your whole explains about architecture of embedded system. Why I'm giving you this topic is, why I'm keeping this topic as self-study is, only if you understand these things, then you will understand all those hardware software co-design, the architecture inside, though we are not going into the software, the process level, which we have studied just a while ago. This is in different level, the OSI layer, the one which we have studied. That is in OSI layer. This one is in hardware level, physical layer. Okay. So that's why, if you understand this part, please try to understand very detailedly. Make a note of this. Actually, Anna, even if it shows with a diagram, Anna. This diagram, where have you seen this diagram? Where have you seen like this diagram? Hmm? Where have you seen? Computer name hai nani? CPU. Yeah, CPU. There is SMPS, there is CD-ROM, there is hard disk drive, there is interface cables, there is motherboard. You need to know the function of each of them, SMPS, CD-ROM, hard disk, which is explained here. And also gives you more information on, like, for example, ASIC. ASIC is one of the hardware that controls your motor speed, that controls this data modulation. Many things are there, Anna. This is very one important hardware, application specific integrated circuit lamidi, and ASIC gives you more information in depth. See, DSP. DSP stands for digital signal processing. Okay, and it is mainly used for program memory, ROM. Okay, ROM gidenlo. See, codec stands for compressor, decompressor of the data. This is also one important block of your computer system or embedded system. Computer system, in a way, it is an embedded system, because in computer system it's both hardware and software. How? With the help of all these components, and you need to know all these components. So I'm leaving this as your self-study. Make a note of this. I'll not give this as an assignment, because more or less it will be all same for you all. All 20 of you will be having the same answer. So what I want you to do is just be honest, okay, and make a note in your notebook. Okay, architecture of embedded system. Make a note. Okay, so you explain with your question, like with a question, like explain the architecture, or with a suitable diagram, explain the architecture of the embedded system. Say you take this question and you try to explain. Chat. No, I'll write it here. So take that question, okay, with a suitable diagram. Architecture of embedded system. Take this question and you answer from this part. Okay, this This is also one important
Sir,
question.
which question?
I've just uh, written in the chat. Did you get
Yes, sir. Okay, sir.
that question? Answer is you don't have to write everything. Just read through. Okay, Anale, you read here from here, and you go till this point, Anasinsi. Okay, around 10 marks. Now, okay, so there are many things. Now I'll directly go to this part. Then only you will understand each component. Then only you will understand this diagram. Okay, architecture of an embedded system. So see, architecture of embedded system has many small components comprised of both hardware and software. Okay, see, hardware components are denoted by black line. Can you see this black line? Black block. Software components are designated by dotted block. Can you see the difference? Can you see the difference or not?
Yes,
Yes,
sir.
sir.
Software is the dotted block, hardware is the solid line, solid block, solid black block. Okay, so hardware nalu gachire tame ASIC, I told you, very important. Microcontroller, very important, because microcontroller is the main brain of the computer. Okay, main brain of the embedded system. But in a microcontroller, connected to microcontroller is your user interface. Okay, user interface in the sense input. We are talking about input output devices, like for example keyboard, LCD, motor, which we have already studied. These are interface. Okay, but it need to be connected to microcontroller first. Then digital signal processor. See, digital signal processor. This is very important because any signal needs to be, in digital form, encoded. It won't take some kind of an analog form. In analog form, the vivade. So that's why we need some of these processors to convert all these, to deal with this signal processing. And our software is somewhere here. DSP assembly code. See, digital signal. There are more than one digital signal processor. Okay, combined with dual port memory. Codec compressor is also there to deal with this. Okay, you'll only know what are all this if you study all of this theory. Or everything is connected by your system bus. Okay, see, system bus. Where is your system bus in a diagram? These are system bus cables. This yellow things. System bus. In software part, I'll say what all are there. Very important, RTOS. See, real-time operating system, which we have done in the last unit, that is RTOS, processes, task. Just introduction, that is real-time operating system. Okay, so see, but real-time operating system is assisted by two things. One is control process and one is user interface process. Okay, these two things is helping this RTOS. But RTOS is not directly given to the system bus, but this has to be programmed. Whatever program you will do the programming in RTOS, which is inside kernel, which is inside operating system, and this is inside your microcontroller. See, directly combined with microcontroller. First, this RTOS is inside microcontroller, then only, okay, you can interface with the main embedded system. So all this needs to be combined together. That's why I'm saying that the hardware software code design becomes very important here. See this point here, somewhere it's written here, Analu. They talk about hardware software coexistence. Okay, see this, both the hardware and software, this line, okay, this line, these lines are very important, man. Both the hardware and software coexist in a coherent manner. Now have you have seen that there is hardware also, there is software also. Okay, so these need to be coexisted together. Tasks which can be both carried out by hardware and software affect the design process of the system. See, what is affecting is the task which needs both hardware and software. Okay, the task which needs both hardware and software affects the design process of the system. Okay, for example, let's this must not be clear to you. Let's have an example. For example, multiplication action may be done by hardware, or it can be done by software by repeated addition. What have you understood? Multiplication, okay, multiplication process can be done in software, in assembly language programming, but in assembly language programming, mostly in microprocessor, in microcontroller, actually multiplication process is done by addition. Actually, in software, in micro, don't misunderstand. Okay, here inside the program, inside the microprocessor, actually microcontroller, though we have written a multiplied by b, a cross b, but inside the hardware addition is happening actually inside the hardware. Like for example, 3 into 10 bewachin, like for Analo. Is there a pointer here? No, there's no pointer. 3 into 10 bewachin, 3 plus 3 plus 3 plus 3, 10 times plus. Okay, this is how it is happening. You have not studied this because these things you will study in microprocessor, because microprocessor you have not touched. Though we have written a cross b, but this is not the case inside. It is happening like how many times a is added. In software we do that. And also division is with subtraction. Division we do with subtraction. So that's why software can do the multiplication with addition, but also there are some hardwares which can deal with this multiplication. Okay, that's why they might do the same function in different way. That might create a problem in same way. I don't know. This is one example, just one example. Hardware based multiplication improves speed at the cost of increased complexity. Hardware nadi speed might increase, the multiplication answer, the product might come very fast, but what need to be sacrificed? The complexity of the arithmetic logic you need. Are you getting or not? On the other hand, see this on the other hand, software based multiplication is slower. The product might come slow, but the design of the arithmetic logic unit might be simple. Now, which one you will choose out of this? Hardware or software? We can't choose because both have to be coexisted. Both have to be coexisted. That's why there is some conflicting requirements which need to be resolved on the requirements as imposed by overall system. That means, okay, hardware ke aneni percentage gobe, सॉफ्टवेयर के अनेनी थिंग्स को वे say they need to cooperate to one another. When we cooperate, when we put these two things together, okay, some things might be lost from software, some things might be gained from hardware, and similarly some things might be gained from software, something might be lost from hardware. This is called as hardware software co-design. Are you getting? And this is very much big part, plays a very big part of your design methodology of embedded system, which comes your next unit actually. So this part is one of the gateway to the next unit. Co-design से लो, partitioning से लो, hardware software partitioning से लो. Okay, are you getting? And okay, so this is just architecture, remember, so we'll not study that much in depth. So I have created a separate note for this more detailing for hardware software co-design. Then this is this part. So I think we'll do this in next class. So just take it this much, Analo. So hardware software co-design will deal more detailing, which I have given the note here in this one, and which this is already uploaded. Partitioning, have a look, okay? And okay, is it clear till this point?
Yes, sir.
Okay, so without much wasting time,